In this video, we're going to look at business examples of predictive regression. We're not looking at any specific regression algorithms such as linear regression or neural networks, but rather the general class of business problems that could be resolved or helped by various predictive regression algorithms. So first, let's look at the general idea of predictive regression. First, we're talking about prediction. This means that we're looking at past data that we have in order to predict what we expect future data to look like. That's the framework we're talking about. So this is predictive analytics. Second, we're talking about regression. And regression means that what we're trying to predict are specific numeric values rather than limited classes or categories. If we were predicting classes such as yes or no, true or false, well, that would be a classification problem. But here we're predicting numbers such as how many customers will come to our store, or maybe how long it takes for a project to be completed. So not categories such as will the product succeed or fail, yes or no, or will the customer buy, yes or no. Those would be classification problems. And finally, this is in the framework of supervised learning. Supervised learning means that there are true answers based on which we can compare to see if the computer's predictions are correct or not. There are true answers from the past, and we can look at how well the computer can predict, and in the future we'll see the true values. We can tell how close the computer was to getting the correct answers or not. I'd like to further clarify the distinction between classification and regression as predictive goals. So first, the basic goal of classification is to predict classes or categories, whereas the goal of regression is to predict numbers. But it's a little bit more than that. When we look at the evaluation criteria of what is a good classification model or a good predictive model, classification really looks at all or nothing. Have you successfully predicted the category or not? So this illustration here kind of shows this point. If you're shooting targets, here what you have is either you hit or you miss. It doesn't really care that much how close the hit is, but if it hits one of the red ones, it's a miss. If it hits the green one, it's a hit. And that's like classification. It's not a matter of closeness or not. It's a black or white scenario. If it's a category you hit that you wanted, it's true. If it's not a category you wanted, it's false. Close doesn't count. In contrast, with regression, the closeness does matter. And so here's another target where there are different points based on how close it gets. The bullseye is the yellow, then closer is red, blue is outer, and then all the way white is a hit, but not a very good one. And that's more like regression, where it does make a difference how close you get. And in fact, in regression, it's very, very rare to get an exact perfect estimate of the correct value, such as in this illustration, none of the arrows actually hit the yellow spot, but a few did hit red, and some were even closer to the center than others, and those are more valuable. Here, you get more points the closer you are, and that's what regression is like. You know that you're probably not going to predict the exact number, but the closer you are, the more valuable, the more appreciated that prediction is. So that's a clearer distinction between classification and regression, especially from the perspective of their evaluation. So now we'll continue with some business examples and scenarios to show where an organization might need regression to solve some of their problems. Here's a marketing example that we're probably all familiar with a company like Burger King or Quick Burger or McDonald's that sells standard hamburger and fries. In marketing, there's a distinction between cross-selling and upselling, which are two strategies to increase sales. And this is a general idea where, with cross-selling, suppose someone orders fries, French fries, and so you as a company, you as a person engaging the customer, you offer them, well, you only want fries? Would you like a meal with that? For example, maybe fries alone cost €2, but if you just add €3, so for €5, you get a burger, fries, and a drink. So with that, you're asking them to buy things that kind of go together with the fries. And so if the customer were to buy these three things individually, they might cost €7 or €8. But by selling them in a bundle, things that typically go together, that's cross selling. Upselling is a scenario where the customer asks for fries and they ask for medium fries, but you say, hey, would you like large fries? So maybe medium fries cost €2, but large fries, which are double the size, cost €3. For the customer, for a smaller amount of money, they're getting double the product. Now, from the business perspective, the biggest cost is the labor. It's not necessarily the fries themselves, but it's the labor that prepares all of these things. So even though the quantity of the fries is doubled, the labor is not doubled. It's exactly the same labor. So the company is actually saving money on selling at €3 for double the price. So the context here is that what effect does cross-selling or upselling have on the sales of fries? So you would have historical information, and based on your historical information on how much fries sales you had, then you can look at when there were cross sales made and when there were up sales made, how much did the price of sales, did the sales of fries increase? So here you're looking at the number of sales, so not necessarily and you could measure it either in the number of units of fries sold, or you could measure it in the euro amount of fries sold. And the variables would be, were there cross sells, were there upsells, or was it just a regular fry sales? And you could see how these different factors affect the number or the total sales volume of fries sold. Because what you're looking for is quantity of fries sold, either in raw numbers or in euros, this is a regression problem. So here's an example from hospitality and marketing. The context probably makes more sense in North America. So, like in Canada, where I'm from, it's very common for consumers to have credit cards that have travel packages associated with them, where the more you spend when your credit card on anything, the more points you get that can eventually be redeemed for travel. And these are often associated with airlines along with their frequent flyer packages. And this is important because consumers who do this have consented to sharing some of their bank card usage information with the travel agency or with the airline. And this is not only beneficial for the customer, giving them discounts on travel, but it's also very beneficial for the travel agency and for the bank because of the large collection of data. So, for example, when the customer's travel history based on the frequent flyer records with the airline that indicates what kind of destinations they normally go to, and with a bank knowledge of their income level, maybe family size, the bank and the travel agency could work together to customize package offers to the clients. And here it's not so much a matter of predicting whether the customer will say yes or no to the package, but it's kind of predicting how much is this customer willing to spend. So knowing, is this a customer that typically maybe each year they spend around $10,000 on their vacation travel, or this is customer more, they're in the level of $2,000 on their vacation travel. And based on this, the travel agency can prepare special packages that might be more attractive to that particular kind of customer. Now, because what the agency and the bank are trying to estimate is how much a customer will be willing to spend, that is a specific dollar amount, a specific number, and that is a regression problem. Here's another example from marketing. One thing that is very common in the retail sales are discounts to attract more customers. And discounts are based on a lot of pricing strategies. Usually, a new product will be sold at maximum price, mainly to attract the customers who are willing to pay full price to get products earlier. And then after a product is no longer so new or so fashionable, then the prices can be discounted because now you're trying to capture more price sensitive customers. By that way, you're selling the same product at different price levels to match different willingness to pay from customers. However, if a company offers overly aggressive discounts, like if they offer 90% discounts, well, everything's going to go off the rack. But what if they could have still sold everything with just 50% discount or maybe a 30% discount? So a company doesn't want to leave too much money on the table with overly aggressive discounts. They need to monitor what are the effects of the discounts they have on their sales, so that when they're trying to make new sales, what is the appropriate discount where new customers will be attracted to buy that would not have bought otherwise, but people will pay the full amount that they would be willing to pay. So looking at this historical information and trying to predict how much, how many products would sell based on different discount amounts is a regression problem, because the company is trying to predict number of sales or euro volume of sales. So with these examples, hopefully you have a better idea of where regression would be a useful technique to solve various kinds of business problems.